let's get back to where we were doing there. We had our phasor diagram. Let's put the current phase shift to be, we'll say pi over 6, which is roughly where I like to write it. That was I sub C equals I sub R equals I sub power supply. I know that my voltage phasor for the resistor is in phase with that. That's VR. VC. We'll have a phase shift, well, it's 90 degrees behind that. So let's write down some stuff that we know. All right, so I have voltage for the power supply. 169.7056 volts, cosine 376.99 radians per second time, plus, I don't know what phi is yet for the power supply. I know that for my current, they're all the same. My magnitude, I don't know yet. Times the cosine of 376.99 radians per second time, plus pi over 6. And I know it's pi over 6 because I said let's make it pi over 6. The current here. Well, I know we've actually solved pretty much for it. I know the current is going to be epsilon, the magnitude of my voltage power supply divided by the impedance. And I know a formula for impedance for this circuit. It's the square root of x sub c squared plus r squared, which is the square root of 53.052 squared plus 100 squared. Which is 120. Someone's supposed to tell me.
113.2.
113.2.
211.0.12134.
Those. My current, so this therefore is 169.7056 volts divided by 113.2 ohms, and we end up with the magnitude of our current. Which is 1.5.
Yeah.
Units?
What's current? Amperes.
Yeah. All right, so we got 3 of the phasors done. See, resistance, the voltage across the resistor. Well, all of that's going to be the same because it's in phase. We just need to figure out what the magnitude of the voltage across the resistor is. Well, IR. I have my current now. I know what my resistance is, so this will be 150 volts cosine of 370, I'm going to round off, 377 radians per second. Plus 6. The last one is the voltage for the capacitor. Well, I know we're going to have cosine of 376 point yada 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 radians per second time. I know that the phase of the voltage for the capacitor is down here in my 4th quadrant. If this is pi over 3 here, no, sorry, pi over 6, what is this? I know that is pi over 6 given. I need to find out that.
Pi over 3. Negative pi over 3?
Yeah. And amplitude is going to be the amplitude of the current times the capacitive reactance. So that is going to be 113.2 times, nope, sorry about that. The current 1.5 times the capacitive reactance, 53.052, which is somewhere around 76-ish, 76 point.
79.57.
Say it again?
79.58.
79.53.
Close enough.
Oh, sorry,
Close enough.
I left the hearing aids at home, so I'm missing out on little things. And the last thing we have is that. I need to figure that out, so I know that my EMF, boom. I need to, if I can figure that angle out, I can figure out the rest of it. And that angle, well, I know this, I have a right triangle here. Right triangle. Oh, actually, down there. Voltage VR, I know is 150. VC is 79 point, what I've written down here, 53, but apparently it's not exactly that. I'm trying to find that angle there. How would you find it?
What's it called? Something and something.
Yeah.
Wait, what?
Tangent.
The phi?
Yeah.
Inverse tangent of something.
Mark tan. I mean, I guess we know the hypotenuse, so you could do an arc sine or a cosine, but we have those 79.53 over 150. And is that gonna be about 30 degrees?
It's my radius.
Alright, so it'd be a little bit more, so 33.5.
27.9.
Okay. In radians, you guys, of course.
0.4878.
0.4878. And so my phase shift here for the power supply, that is not the phase shift. That is the angle from the one that we know. So you would take pi over 6. So that angle there is that. It's pi over 6 minus 0.4878. Which is something that potentially will bring tears to your eyes, tears of joy.
0.0358.
Positive? It is positive, right?
Yes.
Okay. 0.03583. And I don't have to write radians. You can write radians if you feel like it or not. And there we go. We have the full gamut. We know what the formula is. So at this point, if and we were inclined, I could say, what is the voltage and the current for each of the components at 1 second? And now it's just a simple plug and chug exercise. Assuming your calculator is in radians, or you convert before you hit the trig function. And I suspect that's time.
Oh, you're well over. I'm fine.
Only 6 minutes.
I'm fine with it. There's been worse times.
Anyway, here it is. You can now go and weep tears of joy for having had the experience of being here.
Every day.
Yes, darn straight.